All right, we're going to close out P4 here in your pre-calc books, talking more about some linear equations, some lines. In this case, students will be able to write equations for lines in slope-intercept form. So that's our mx plus b. And find equations for parallel and perpendicular lines. Remember last time we talked about point-slope form, y minus y1 equals m times x minus x1, which is my favorite form just because it's really useful for lots of different situations. This is a specific one that you learn first. So let's talk about it a little bit first. Our vocabulary, line once again, and slope and intercept. Parallel lines and perpendicular lines are words that we'll be focusing on. So let's talk about slope-intercept form first. So this, I think the reason that this is taught first, it's, I think, not a real useful form for a line. I think the reason they teach it first is because it's easy to graph. So like if you have a line y equals, so mx plus b is our slope-intercept form. And this is a line with slope m and y-intercept b. And this is really just from point slope form, and it's a specific point. So like, let's, a real quick example. Let's say you have y equals, like, I don't know, 2x minus 1. So our y-intercept is -1, that's right there. And then the 2x is the slope, so it's going to be a pretty steep line, something like that. So pretty easy to graph, but when you think about it, really all you're doing here is you're using point slope form, and you're using a specific point. So point slope, remember, y minus y1 equals m times x minus x1. If we're using the y-intercept, whatever it is going to be x1, sorry, 0 comma y1. Right? Because if we're on the y-axis, the x-coordinate will definitely be 0. So the y1, let's call it b even, because that's what we are used to for y-intercepts. So 0 comma b, in this case 0 negative 1, is going to be our y-intercept. So you put that into point slope form. You have y minus b equals m times x minus 0. Well, x minus 0 is just x, so I have y minus b equals mx. Add b to both sides, y equals mx plus b. So that's where it comes from. It's a specific case for point slope because we have the slope, it's the same thing, it's that m. And then instead of having an x1, y1, we have specifically 0 comma b. And that's really the only difference for slope-intercept form. It's not that exciting. And you can write any line in this form if you just move everything around and solve for y. So let's take a look at trying that last problem we had in our last video for point-slope form and trying to convert it to slope-intercept form. And we had two solutions in the last video, so we'll write them both out again and see if they both give us the same thing. It's a good way to check to see if two lines are the same. So our slope, remember, change in y over change in x. And let's go this way. So -2 minus 2 divided by 4 minus -1, which is -4 over a positive 5. So we have our slope. And now let's put it into point slope form because we have a point. We can use either one. So this is where I said, I'll do one way, and why don't you do the other? We'll see if we get the same thing. I'm going to use -1, 2. So I have y minus 2 equals -4/5 times x plus 1. Okay, so I use this one. Why don't you use y plus 2 equals -4/5 times x minus 4. And why don't you solve this one out over here? I'll solve this one out over here. We'll see if we get the same thing. So I'm going to distribute in that -4/5. So I have y minus 2 equals -4/5 x minus 4/5. And now I'm going to add 2 to both sides. So y is equal to -4/5 x minus 4/5 plus, let's think about what 2 is in terms of fifths. I think that's 10/5 because I want to add those together. So I have y equals -4/5 x. -4/5 plus 10/5 is a positive 6/5. There we go. Did you get the same thing? Well, let me give it a shot and see if we get the same thing. Y plus 2, -4/5 x plus 16/5. Now I'm going to subtract 2 from both sides. Well, 2 in terms of fifths is 10/5 again. So y is equal to -4/5 x plus 16/5 minus 10/5. Hey, check it out. -4/5 x, whoops, plus 6/5. Same thing. If I wrote a 5, it would be the same thing. There we go. So no matter which way you do it, you're going to end up with the same slope-intercept form. So it's a good way to check to see if it gives you the same line. All right. Let's try parallel lines. So parallel lines, you guys have probably heard of parallel lines before, kind of like railroad tracks, right? They go forever and they never touch. So if you have two parallel lines, like these, they share something in common. They wouldn't have the same equation, right? Because they would have different points on them. They don't share any points in common at all if they are truly parallel. But what is the same? Well, it looks like the rise over run is going to be the same for every single one of them. Okay, so parallel lines have the same slope. So if you want to check if two lines are parallel, solve for y equals mx plus b. The other one might be y equals mx plus, I don't know, c. So different y-intercepts, different points overall, but same slope. So let's try a problem. F of x equals 2/3 x plus 3. Write the equation of the line parallel to f of x through the point -4, 6. So I've got a point. What's the other thing I need to make a line? I think I need a point and I need slope, right? So my slope, I don't know yet, but I might be able to get a clue from f of x. We want it to be parallel, so it's going to have the same slope as this line. Do I see the slope in here? It's 2/3. So it's 2/3. So now I have a point and a slope, and we just put it into point-slope form. Y minus 6 is equal to 2/3 times x plus 4. They didn't say what form to put it in, so I'm just going to leave it like that. Point-slope form. If I did have to put it into slope-intercept, I would distribute the 2/3 and then add 6. So common denominator with 6 would be 18/3. All right. Let's try perpendicular. Perpendicular lines are a little tricky because people always forget how the slopes are related, right? Parallel lines, people remember that's the same slope. That's not too bad at all. But this next one, we have to think, well, what do perpendicular lines have? Well, first of all, perpendicular means that the lines are orthogonal, or at a right angle to each other. So let's draw two lines that are orthogonal. There we go. Okay, so a right angle to each other. Could be more like this, right? But the important thing is they're definitely at a right angle. So if we graph this on the Cartesian plane, here's one line, here's the other. So let's say the slope of this line is like 1/2. Let's look at the slope of the other line. Often, like maybe on the ACT, you would have some multiple choice. So they might say this: which one of these slopes is perpendicular? You might have -1/2. You might have 1/2 trying to get the people that think they're parallel. And you might get -2, and you might get 2. So the way I always think about this is think about taking these lines and actually rotating them. So like taking them and keeping that right angle, but rotating them. So this line is going to get steeper, and this line is going to get mellower. So maybe something like this. So like this line starts off like that. They're orthogonal. Then this line's getting steeper and steeper. What's happening to the other line? It's getting mellower and mellower. So this slope is 1/2. Maybe this slope is like I don't know, like 1/4. Maybe this one's like 1/8. Look at the other line. It's getting steeper and steeper and steeper, and the slope of this is definitely negative, right? So the slope of this is negative, and it's getting more and more and more negative. So maybe this slope is like -2. Maybe this one is like -4. Maybe this is -8. You see that the shallower that the flat line becomes, the steeper the other one has to become. So we have a reciprocal relationship. A reciprocal relationship, and it has to be opposite. If the slope of one line is positive, the other one's definitely negative, and the more shallow this one becomes, the steeper the other one has to become to keep up with it. So if the slope of line 1, so if the slope is m, then the perpendicular line, that's often a shorthand we use for perpendicular, has -1/m slope. Okay, so let's check for our line. We had a slope of 1/2, -1/1/1/2. 1 divided by 1/2, 2 halves fit into a 1, so that is -2. So always opposite reciprocal. There's a proof of this. It uses trig and the Pythagorean theorem. You use the fact that this is a right triangle, and then you use these 2 points right here. You put the line into point-slope form, and you can prove that these 2 slopes are opposite reciprocals. It's a pretty cool proof. All right, let's try this. Looks like I have to get rid of some of my stuff here. All right, so we have our line, 2/3 x plus 3. And once again, we want to find the equation of the line perpendicular to that function through the point -4, 6. So I have my point. I need a slope. Well, the slope of the original line is 2/3. If I want it to be perpendicular, what does that mean the slope's going to be? The slope's going to be -3/2. So we have y minus 6 is equal to -3/2 x plus 4. That's all there is to it. Stop right there. If you want to distribute it in, feel free. I'm not going to because this just seems a heck of a lot easier. All right, one more example with that other form. So that other form, no one ever uses this, right? You might have seen it back in Algebra 1 or Geometry. ax plus by equals c. This is called standard form. And standard form is useful if you want to find intercepts of a line. But other than that, sometimes in a real life situation, like you're selling, so many t-shirts for so many dollars, sometimes you'll have some kind of an equation like this, but it's really not very useful in math. So let's see here. We're looking for the line perpendicular to this line, L, through the point 2, -3. So I have the point. We need the slope. Well, first we need the slope of L. So L is 4x plus y equals 3. This is kind of sneaky. We got to solve for y to get the slope. -4x plus 3. So there's our slope. So then the slope of our perpendicular line is going to be the opposite reciprocal, which is 1/4. We've got a point. We've got a slope. Let's just put it together. Y plus 3, 1/4 times x minus 2. That's it. I tell my calculus kids that you should be able to write point-slope form in your sleep. If you have a point and you have a slope, you got to be able to get it to point-slope form. It's not that bad. Just y minus the y-coordinate equals the slope times x minus the x-coordinate. And that's all there is to it. All right. That's it for P4. Give their homework a shot. I love you guys. That's why I'm here. Have a great day.